let's solve our range equation for the initial velocity. So our initial velocity here is v naught squared. R is the range. G is our acceleration due to gravity. That's our 9.8 meters per second squared. And the angle theta at which we're initially launching is the angle theta 0 there. Let's go ahead and solve this for v naught squared. This is algebra that, in most part, when you're working on your homework, I'm going to assume that you are already going to know how to do. So let's go ahead and practice with that here. So to get v naught by itself, we have to get rid of that g on the bottom of the fraction on the right side. So I'm going to multiply both sides by g. When I do that, that cancels these g's here. So I've got rg equals v naught squared sine of 2 theta naught. Okay, now I've got to divide both sides by sine of 2 theta naught. So just to be sure that you understand what this is telling us, we're going to take the sine of 2 times the initial angle at which we're launching. So if our initial angle that we're launching at is 20 degrees, we're going to multiply it by 2. That gives us 40. So then we'll take the sine of 40 there. So I'm going to put that 2 theta in parentheses to remind us that the 2 times the theta is the argument of the sine function. So again, it's not multiplying sine by 2 theta. It is taking the sine of 2 times theta. So I'm going to divide both sides by sine of 2 theta naught. 2 theta naught. So then I have v naught squared is equal to rg over sine of 2 theta naught. Okay, and now I just have to get rid of that square on my initial velocity. So I take the square root of both sides. So then I have that v naught is equal to the square root of rg over sine of 2 theta naught. Okay, so all of that stuff is underneath the square root sign. So you take the range times the acceleration due to gravity, and you divide it by the sine of twice the initial angle at which you launch. Okay, and so that is how you solve the range equation for our initial velocity.